Alright, so in this problem, I have 4 to the power of x plus 6 to the power of x is equal to 9 to the power of x. So to solve this, I'm going to divide both sides by 4 to the power of x. So I get 4 to the power of x over 4 to the power of x plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. Now, 4 to the power of x and 4 to the power of x cancel out, so I get 1 plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. And if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, 6 to the power of x over 4 to the power of x is going to equal 6 over 4 to the power of x. And 9 to the power of x over 4 to the power of x is going to equal 9 over 4 to the power of x. Now I can simplify these fractions. So 6 over 4 is equal to 3 over 2. And 9 over 4 I'm going to rewrite as 3 squared over 2 squared. And I can actually use this property again for 3 squared over 2 squared. So that's going to equal 3 over 2 squared to the power of x. And if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of n to the power of m. So this can equal 1 plus 3 over 2 to the power of x, which is equal to 3 over 2 to the power of x to the power of 2. Now I'm going to let 3 over 2 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y minus 1 on both sides, these 4 cancel out, and I get y squared minus y minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared minus 4ac. So negative 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. Now this is equal to positive 1 plus or minus square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So y is equal to 1 plus or minus the square root of 5 over 2. However, we're not done yet because we're not solving for y, we're solving for x. And remember how we let 3 over 2 to the power of x equal to y. So this gives me two equations. I have 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2, as well as 3 over 2 to the power of x is equal to 1 minus the square root of 5 over 2. Now to actually start, we can already cancel out one of these equations, which is the right-hand one, because 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it equal a negative number. So this equation wouldn't even work. So the only equation I have left is 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. So now this turns into x times log 3 over 2 is equal to log 1 plus the square root of 5 over 2. And now if I divide both sides by log 3 over 2, I get x is equal to log 1 plus the square root of 5 over 2 over log 3 over 2. Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number because 9 to the power of 1 is 9 and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent and b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4 because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution.